Don't watch this video. That's right. I'm not going to show you how to do anything useful in this video. I'm going to be covering the vector manipulation tools in Affinity Photo's procedural texture filter. However, I've yet to find any use for them. I understand what they do, but usually I can find a better way to do the same thing. I thought I'd better cover them because I saw another YouTube video where someone was using them improperly. I think they thought they did something that they didn't do. I'm going to cover them. There's actually quite a few of the vector manipulation tools, although in most cases the functions are repeated. They just have different names and they do exactly the same thing as far as the vector is concerned. So I'm not going to cover any cool textures in this video, and most of the techniques I'm going to show you could be accomplished in a simpler fashion. Vector manipulation is known in the shader world as swizzling, and there it actually is a very efficient way to do things. Swizzling is used extensively in Blender and Shader Toy and just about any other shader programming language. But for the procedural textures, I haven't really found a case where I couldn't do it a different way without swizzling. I have used one of these functions a couple of times. My background here is a picture I took in Kew Gardens about 2 years ago. And it shows what you can do if you use the vector manipulation functions to apply to the red, green, and blue values in an image. These are some of the different effects that you can get doing that. I guess it could be sort of interesting if you're trying to create something that looks like an alien landscape. But generally, I don't think they're really that useful. And there are other ways to change the colors around if you're using them. So I'm going to go over all of the different vector manipulation functions, and they work with vectors. Some of them are primarily designed for vec3 vectors. Others work with any number of element vectors, and I think the vectors can go up to 6 elements. I took this picture in the gardens of the Palace of Versailles, and I'm going to show how to use some of the vector manipulation functions using this image. We'll start with a procedural texture. I'm going to add a single equation to it, and I'll assign it to all 3 channels. So now my picture has gone away, but I'm going to bring it back, and I'm going to create a vec3 of capital R, comma, capital G, capital B. So those are the red, green, and blue color channels. And so when I put that in, it assigns red to the red channel, green to the green channel, blue to the blue channel, and I get my picture back again. Now I could mess with this. So I could change the G, the green, and the red channels around. Just like that, green, red, and blue. And if I show that one, now my colors have all changed places. Another way to do that would be to use one of the vector manipulation functions. And the one I'm going to use is swaprg. And when I apply that function, it swaps the red and the green channels. There are 2 other functions that do the same thing, exactly the same thing. Swap12 exchanges the first 2 elements of the vector, which in this case are red and green. So that gives exactly the same result. And the other one is called swapxy. Swapxy exchanges the first 2 elements of the vector and gives exactly the same result. Another one is swaprb, so I could exchange the red and blue channels, and if I do that, I get that result. I could do a swap13, which is the same as swaprb. There's also a swapxz, which is the same as swaprb and swap13. And then the last one is swapgb, which exchanges the green and blue channels. which is identical to swapyz. Also, there's swap23. So using these swapping functions, you can exchange the channels. Another vector manipulation tool is the reverse vector manipulation tool. And so that's going to take the reverse of RGB, which will be BGR. I get that effect. And this, it turns out, in this case, is the same as swaprb. Another vector manipulation tool is rotl, which rotates the vector to the left. So if I'm rotating it to the left, that means the first element gets pushed off, and that's going to jump back to the end of the vector, and then the other two elements of the vector are going to move over to the left one notch. So that's what that looks like. And then there's rotr, which means rotate to the right. So the one on the far right is going to get pushed off, and that's going to come back to the beginning, and the others move over one notch. So that's rotr. You can have vectors with up to 6 elements in Affinity Photo's procedural texture filter. I'm going to create a coordinate vector, v equals vec2 of rx comma ry times a divided by h, and I need to put in a custom input a and turn off the alpha channel. I'm going to do some vector manipulation on this one. So one of the things I could do is swap 1, 2 like we did before, and if I apply swap 1, 2, you might guess what will happen. It changes the red and green around. Let's look at V again, like this. Another one I could do is negg1. So this will negate the first element. So it basically flips the x-axis, so the positive x direction is over on this side. Now in a typical Cartesian coordinate system, the positive direction for y is pointing upwards, and some of the shader software out there uses that orientation for y, where it starts with y being 0 down in this corner, and then increasing up to 1 as you go up towards this coordinate up here, this corner of the image up there. So if I wanted to work that way, I could negate 2 of v, and that changes it around. So my x is still going positive this way, but now my y is going positive in that direction, and I have this orientation. So that's a sort of a useful way to use that particular function, but you could just as easily have written a negative in front of the y, and it would do pretty much the same thing. There's 3 versions of each of these. Neg1 will invert the first element, negx does exactly the same thing, and negr does exactly the same thing. You can do neg2, where you negate the second element, so you have a pattern like that. You can call it neg-y, does exactly the same thing. And the last one in this group is neg-green. We're going to create a 3-element vector now. It consists of rx, ry, and rx plus ry divided by 2 for the 3rd element of that vector. And then I'm going to try some of these vector manipulation tools. I'm going to double click over here, and I'm going to do negate 3 of v, like that. So move my blue channel over from over here over to there. And then I can negate z, and it looks exactly the same. It does exactly the same thing. And the last one that's also the same as negate b, which changes the blue channel. The other thing I could do is negate 1 and 2, makes both the red and green channel negative and leaves the blue channel unchanged. And identical to that one is negate xy, negate rg. I can apply the reverse function on this. So instead of red, green, blue, I'll have blue, green, red. That looks like that. and then I could rotate right or left. So let's do that. I'll rotate left, ROTL, and it looks like that. And I can rotate to the right, which looks like that. Now, these vector manipulation operations are very efficient when done on your graphics card. So they don't cost very much in terms of operations. So if you did a sort of complicated calculation, maybe you're rotating coordinates and now you wanted to swap the x and y around, then you can easily do it with one of these vector manipulation functions. About the only one I've used is the swap x and y to swap around my x and y coordinates, and usually I later thought of an easier way to do that where I didn't need to use the swap xy function. But that's what they do. I've seen them used in a way, I think somebody thought that the rotate R or rotate L would actually rotate the image, which it does not do. It just rotates the elements of the vector around. So it shuffles those vector elements around to different positions. I haven't talked about the vector manipulation functions before, but I thought it would be a good idea to cover them so you know exactly what the vector manipulation functions are and what they do. I haven't found a real useful application for them in the procedural textures yet, but that doesn't mean I won't find it in the future. So I'll keep looking for it, and as I learn more about shader programming, it may be that these will become more useful at some point. Let me know if you have any comments or questions, and thanks for watching.